Good day to this webinar, another one in the series of 2 tokens. Welcome wherever you are. Good morning, good evening. I'm very excited to have a very deep, in-depth discussion with EUTO, which is a new player in the market of energy automation. I'm following EUTO now for a couple of years, and I'm very, very enthusiastic and thrilled about the progress that they make and the concept they have implemented. So let's first get an introduction. So Vincent, please introduce yourself.
My name is Vincent van Kalkeren. I actually have a really various background. So I first started in finance actually. Then I became a self-employed professional and entrepreneur. I started investing in startups, and I did a big assignment for Ingrid Thijssen. So therefore I actually really knew the energy transition and all the problems and all the capacity and the net congestion that was already starting already in 2015-16. I met Ali in 2022 when Ali was participating in a startup bootcamp, an accelerator program. And he was actually, or he had already developed a product actually. So it was really exciting. And I first wanted to know Ali as a person a bit better. And after that, I decided to do a follow-up investment outside of the fund and to actually help Ali and to cooperate with him for business development in the Netherlands. So we're now working together almost 3 years, more than 3 years actually already. Yeah. So I'm also really enthusiastic because I actually see the thesis playing out now. So it's also still a lot of work to do, but we're really enthusiastic.
Yeah. So Ingrid Thijssen, for the international audience, was the former CEO of Alliander, the biggest distribution grid company in the Netherlands.
Yeah.
Okay.
Yes.
Okay. Ali.
Yeah, thank you. Yeah, my name is Ali Karademir. Yeah, I'm co-founder at EUTO. I have a quite technical background actually. I am computer and telecommunications engineer. Graduated in 2011 from bachelor's, then master's, and during the last years of my PhD, I started this journey in 2017, founded EUTO Energy. So, and background from these early years, even before, is coming from protection and control systems in the distribution and transmission networks. As OEM projects, we have completed a couple of successful projects, developing protection, automation, control devices and softwares. This is our both technical validation, also how we developed our know-how in the company. Also around 2019-20, we have transitioned this traditional know-how, but the core of the networks, core of the energy networks know-how to new generation solutions, which we call it software-defined energy networks, virtualized grid, let's say, briefly. That maybe we will be talking about more. And personally, from 2017, last 8 years, I am fully dedicated as an entrepreneur to EUTO Energy with our team. And today it's operating from Amsterdam and having also an engineering team in Istanbul.
Okay.
Yeah.
Thank you very much. So, then start off a little bit with you, Vincent. So, what's the problem space that you're interested in that EUTO can be a solution or solve issues?
Yeah, and mainly I think the net congestion problem, as everybody knows. So as everybody knows, the network now is not that intelligent, and there's a big threshold, which also the DSOs are using. And when you have a more sophisticated protection and control, Ali will go a little bit more deeper in that. You have a more system-wide intelligence. So you know what's happening in the system. And therefore, the threshold doesn't have to be 30%, but can be a lot less. Yeah. And by knowing what's happening in a certain area, so it can be in the whole grid, but can also be at a business park, for example, with several companies. The real net capacity, what is actually over there, is sometimes only 70%, but there's still net congestion because of the peak problems.
Right.
So if you can balance that out much better, then more people have energy with already the infrastructure what is there. So actually what we are doing, we are freeing up space to max out the capacity of the existing grid, but also of the grid what you are expanding.
So and how does that interplay with all the contracts? and the different connection and transport agreements that are available.
And it's, I think, something what is in a developing area, I would say. So the big DSOs are busy. Yeah? I last had a presentation also at Alliander. So we will follow that, but we are now already applying our solutions. So for example, in the big business park in Arnhem, IPKW, we are putting there a flexible capacity system. All the tenants get a really low amount, fixed amount of capacity, and all that really big pool is redirected by our system to the company who needs it. They can also make a reservation. So the real, how does it work? To prove it already in action, in practice, that's what we already can do. And the more contracts will come up, which makes it easier for companies to do that, because where we are at Arnhem is important to know there's a GDS, so there's one owner. And they have different tenants. So I think those contracts will make it easier in the future, that you can act upon more like a GDS, but still there has to be a lot of social innovation, I think, between the entrepreneurs, because that's quite hard, what I see in the market, and that they share and that they will be owner combined of a pool of energy.
Right.
So that's more the stuff.
A lot of issues. Yeah. So, but to chime in, Ali. So, what's the traditional way of fixing that monitoring and protection and control? And what's then your approach to it?
Yeah, traditional is a very how can I say, cumbersome process from many perspectives. They are very hardware-centric, that those energy giant companies were dominating the market so far, last 40, 50 years, with their hardware-centric business models, selling a fixed functionality hardware for each functionality. Those systems were working good with the traditional generation, because traditional generation, fossil-based generation can be under your control. So, but the new generation, also also flexible consumption, that is creating a less predictable structure, highly fluctuating dynamics in the system. Those traditional approach is not solving the problem. Also, with the electrification, people need more electricity and grids needs to be expanded. These are two core problems. Today we are focusing on, with our solution, using the existing with more efficiency and helping the operators expand easily. What we have transitioned here, to your question, created a more software-centric solution. Like the journey happened 20, 30 years ago in the telecom networks, from hardware to software and intelligence, the value shifted from hardware-centric solutions to software and intelligence layer, by still having a reliable, time-sensitive hardware at the edge. This is what we see is happening in the energy networks today. So we have developed a software-centric virtualized stack, communication, protection, control, automation, visualization, and cloud connectivity layers, and fully virtualized. Hardware agnostic, platform agnostic, can run all the platforms in a full functional way. That is, first, eliminating a lot of costs, hardware costs, infrastructure costs, also technical personnel needed for expansion for the grid operators. And the second is giving a huge capability to provide extra flexibility and intelligence to the operation, because it's software. This IT level intelligence can be immediately, efficiently, in real time connected to operational OT environment. So this bidirectional data access between those layers, making the systems more intelligent, more flexible, more adaptive, especially for the changing dynamics of the grids, also helping this expansion of the operators.
So then explain a little bit then on what's happening in your system compared to traditional, right? So if you do protection, you need to have selective settings so that the least area of the grid is being disconnected when there is something in overcurrent situation, for instance. But now in the grids we see bidirectional energy flows.
Yeah.
How does that go with all the protection settings, and how do your system then can handle that?
Yeah, the traditional protection settings are static. So they are configured by the operator or technical personnel, maybe even through the local HMIs of those hardwares.
Yeah,
This is quite static. But with the continuous changing of the grid dynamics, that also needs to keep the system always optimized and balanced. That's why sometimes even the operators are not able to understand it very well, but these are causing some big faults, big problems. So with our solution, again, thanks to having a software-centric approach, now these settings are now dynamic set points. That is also called adaptive protection and control. So now the settings, the threshold, the set points can be all the time adjusted, autonomously adjusted in real time based on the dynamic changes in the grid. This is also creating an extra availability for utilizing more capacity to the consumers, because once you wanted to utilize more capacity from the existing infrastructure, of course that brings some risks. That's why this 30% safety margins were applied. But you want to use it more to eliminate the risk at the same time. This dynamism, this flexibility, intelligence is providing to keep the system more efficient, at the same time keeping safe and reliable.
Okay.
And I think it's good to notice, Ali, that the grade of autonomously, and that the system really does it autonomously. And we get that question quite often, because in the beginning they don't like it if it happens totally autonomously. And that in the system it's really easy to put some checkups in for a control room, etc. That you first want to pivot a bit, and then later on you let it go autonomously. So our system is there also really flexible.
Oh yeah. That the organization can learn and trust, and then let go if they are fully trusted in. Okay. Yeah. So, and what are some other kind of aspects that you foresee and see a good use of your system? Yeah. So we just, this was the flexibility of the control point and the safety settings. Yeah, the set points turning into dynamic. And what are other use cases?
One of the biggest values of such solutions is replacing hardware with software. So in a distribution or transmission substation, it's replacing 50 plus traditional hardware with only our software running on a single or two redundant, highly capable substation computers. So these industrial substation computers are providing us a reliability and time sensitivity for processing, also for communication. And functionally, our software is replacing all those 50 plus hardwares.
So a question on that, to be skeptical.
Yeah.
And I think you received those questions already, right? So when I visit substations, I see electromechanical equipment still there, 20, 30, 50 years old.
Yeah.
I see multi-vendor solutions. So one field is ABB, the other field is Siemens, and then so there's a huge struggle from engineering and also maintenance and doing the settings. You need a lot of different skills at the site at the same time because it's all controlled access. But one of the benefits is that there is no single point of failure. If one supplier fails, not the whole substation goes down, and now it all is depending on, the hardware is redundant, so that's a check mark, okay, but it's your software. Yeah, that's a single point of failure.
Not actually, because one of the core purposes from the operator's point of view also avoiding vendor lock-in with such systems. In the traditional systems, there was a huge vendor lock-in because once ABB is sold its first product, then the rest of the product should be ABB because the interoperability was not so high level. So with such systems, operators are really targeting eliminating such vendor lock-ins. And our solution is intentionally designed for a high level of interoperability that can immediately work with others. And also backup protections, backup systems will always be there. In a substation computer, our machine, our virtual machine is going to be there. Maybe other providers, other vendors, protection, automation, communication, control, virtualized applications will also be there. And they are going to be used as primary, secondary, backup, and primary systems. So it's, for example, in the telecom network, these are also managing a critical infrastructures.
Right.
So hospitals, military operations, but they are transitioned from hardware to this fully software-centric solutions. We are also seeing from that perspective. Of course, this is going to take time. This is a journey of all sectors.
Right.
Testing companies, hardware manufacturers, application providers like us, and all other participants will contribute to this process.
So what do you then typically see is in the process, right? So if you have multiple vendors in a substation, then changes is quite a lengthy planning process to start with. Yeah. So and then all the people needs to be on site at the same time, and then the changes need to be applied, and then it needs to be tested, validated before it goes into live again, right? So how is that process changing in your solution when the substation is equipped with EUTO, running on industrial edge computers, right?
Yeah, if we make it very simple, just a click software update, but of course it's not gonna be like that. But
how will everyone trust that the changes are working as?
Yeah, that's why today, for example, test companies are working on also adapting this change, this shift. So far, the testing companies were having their testing devices. Sometimes, a few times in a year or in a few years, technical people were going to substations testing equipments. This was again, practices of the traditional systems. Now they are also working on putting their test devices all the time installed in the substations and making these updates in the system more frequently and more dynamic.
Okay.
We will deploy our application, or maybe hardware manufacturer will update its BIOS settings, something, or the hypervisor operating system vendor will be updating something. Before making it operable, will be tested by the test system, third-party test system, and then will be making operable. So this process will also be autonomous and almost fully remotely controlled. So the technical personnel does not need to go to site physically. This is also taking a lot of time and money and limitations to risks, etc. So we are seeing this journey from this perspective.
Right. But then I have a question. So when you reflect back on the time where we wanted to give the engineers access to the protection and control systems remotely, that cybersecurity was a huge blocker. Yeah. So how did you address that point on cybersecurity? Because you're running on the edge. You can do over-the-air network updates, configuration updates. You have a cloud component. How does it?
Yeah, at EUTO Energy we are focusing on the applications where we are good at, and we are partnering with hardware manufacturers. They are handling the security of the hardware, encryption, etc., and network providers, companies, integrating our solutions together with them, and immediately access their all cybersecurity features and availabilities. And the systems, again, from the operator's point of view, of course, defining all these steps in this journey. They are working on this virtualized, software-defined substation or grid operation topics from all those perspectives. Also training their personnel for these practices so far, because they were trained for tens of years for traditional
PLC
practices.
equipment.
And now they should be first have this new mindset and really trained, practiced for such change.
Okay.
I think it's also something what we really notice about the security part. Yeah, so I also spoke to a head of strategy and another CEO of a DSO. And what we see all the time over there, because the reliability part, because it's also a risk, that we also say then, do you want to drive in the fog or with a clear view when the sun is shining? So with that software, what you are going to use, you have much more visibility, you have much more system-wide intelligence, and of course, but it's with also the telecom network, etc., and everything what we are using with IT, that you have to have a good cybersecurity.
Right.
So we think it's an important point, but it must not be a kind of argument that it then is less reliable, because we say it will become more reliable at the end.
Yeah.
So,
okay.
Different perspective.
Yeah. So we were discussing a little bit the application area. So substations in distribution and transmission grids is one. Closed distribution networks is another one with on campuses, on industrial parks and what have you. The question then becomes, and I know which one to direct my question to, is the proposition for a substation is, I think, quite different than from an industry park, in the sense that traditionally asset managers in grid operators run their investments over 30 years life cycle. Not accustomed to service fees, monthly updates. It's install and forget, more or less. So how does that all play out? All those different business models that you want to address.
Vincent explained is as we have a DSO, TSO level platform can be applied to the business park microgrids, because we have a platform which maybe the most critical layer of this platform is DSO, TSO level distribution, transmission system, protection, automation and control systems, from time sensitivity, from functionality, from algorithms inside, reliability. But it has layers, software layers, data access, protection, control, automation, visualization, builder, and cloud connectivity to making it more intelligent. And this can be packaged with different forms. Having even in the DSO level verified, validated solution in this layered structure can make us really reliable in the microgrid environments, business and park environments, but the eventual target is the same: resolving congestion problems in the network, capacity problems in the network, providing the electricity, energy to the consumers when they need in a reliable way, and helping the operators to do it in an efficient way. So eventual bigger title is the same, making it in different ways. Of course, also we are running some industrial park applications, also microgrid applications on the islands, even off-grid island. We are doing some projects, but the product base is
the
same.
Okay, so then my final technical question for now is that you run from the cloud. Is it cloud agnostic, or is
it's a combination of edge and cloud. Cloud should not be always there. It's kind of an optional connectivity. We can also provide all the functionality at the edge level, edge hosted components, because we know that especially distribution transmission domain, this cloud internet connectivity is not always possible and also intended. So, but if the application, the project is available to connect the cloud, of course, this can boost the functionality, the features, the intelligence to the system.
Okay, thank you. So, and then a final one, Vincent. So, what questions are still on the table? And then at the end, so if people want to know more about EUTO, where did they go? Who did they contact?
but they can just contact Ali or me. They can book a demo on the website also.
Okay, and what's your website?
Website is EUTO Energy.
EUTOenergy.com.
Okay.
And what we mostly do, because what we see, we actually also have a little bit of a Swiss knife. You actually asked us, Ali, just a few minutes before, how do you actually handle those different markets? And also because it's really kind of paradigm shift, what we are doing. So what we see, what helps a lot, just ask us, we come by, we have sometimes 3-4 hours brainstorm session, sometimes 2, with all high technical people or less technically people. And we actually have a kind of benen op tafel sessie in Dutch. So the boots on the table, and just to brainstorm and to let them see what's all possible.
Right.
And then you're really looking into how does the future look like. And then from that point on, they can get all kind of links for themselves. Oh, but we can use it over here, we can use it over there. Because we didn't go really into that, but we actually have a kind of substation automation vision. This is not only the virtualized protection and control, but also a virtual RTU, a virtual HDMI. So there are more use cases, so to say, what you can do with the same stack.
Yeah.
And that's actually also really market defining now. So we are also learning all the time.
Okay. So thank you very much. So thank you for this webinar. So if you have any questions for a follow-up webinar and you want to ask some questions on EUTO, please share them with us, and then we schedule another webinar session to go and deep dive a little bit, perhaps show some of the product features. For now, thank you very much. Thank you for watching, and until next time.
That was it for today's podcast. Thank you for listening in, and please subscribe so you don't miss out on our upcoming episodes. If you want to get in touch with us, you can find our contact details at www.2tokens.org.